Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 2, that is Electrostatic Potential and Capacitance. From basic to advanced level, for board, JEE, KCET, and NEET. Only subscribed one can get PDF. So watch till end, don't forget to comment, share, subscribe the channel. In previous class, we studied Chapter 1, that is Electric Charges and Fields. That video link is given in description, don't miss it. Today, starts with Electrostatic Potential. Let's start. Chapter 2. Electrostatic Potential and Capacitance. Start with basic. Electrostatic potential, or electric potential. Electric potential at a point in an electric field is the work done in bringing a unit positive charge from infinity to that point against the electric field. Or the work done per unit positive charge to move a charge from one point to another in an electric field. That is electric potential. V is equal to work done by charge. That is V is equal to W by Q. Here, SI unit is joule per coulomb or volt. Potential is a scalar. 1 volt is equal to 1 joule per coulomb. Next, potential difference. Electric potential difference between the 2 points is the work done by an external force to bring the unit positive charge from one point to another point. From figure VA and VB. B potentials at 2 points A and B respectively in an electric field of strength E. Therefore, potential difference is equal to VB minus VA. Here, SI unit is joule per coulomb or volt. Potential goes on decreases along the direction of electric field. Note 1. Both electric potential and potential difference are scalar. 2. SI unit of both electric potential and potential difference is volt or joule per coulomb. 3. Electric potential at infinity is taken as 0. 4. Electric potential is the property of a point and is independent of the path traced by the charge. Electrostatic potential energy. Consider a source charge, Q. Let E is electric field due to a charge Q greater than 0, that is Q is the positive charge. Q0 is test charge. Q0 greater than 0, that is Q0 is the positive charge. When we bring a test charge Q0 from a point R to P, then Q charge produces repulsive force on Q0. Therefore, an external force is applied on charge Q0 to bring it from R to P. That is, external force is equal to minus electric force. Net force on test charge Q0 is equal to 0. As a result, the test charge moves with constant speed and with zero acceleration. The work done by the external force in moving a charge Q0 from R to P is WRP is equal to integration R to P, F external into dr. Because let dr is equal to small displacement of Q0. dW is equal to small work done. Therefore, dW is equal to F external into dr. Therefore, total work done is equal to W is equal to integration of dW. That is equal to integration of F external into dr, where dr is equal to displacement. WRP can written as WRP is equal to minus integration R to P of F electric into dr. Negative sign indicates that work done is against electrostatic repulsive force. This work done is stored as a potential energy. At every point in the electrostatic field the charge, Q, possesses certain potential. Energy. If R is at infinity, then W infinity P is equal to minus integration infinity to P of F electric into dr. But work done is equal to potential energy. Therefore, W is equal to U. Above equation written as U infinity P is equal to minus integration infinity to P of F electric into dr. Therefore, potential energy of a charge Q0 at a point is the work done by the external force to bring that charge from infinity to that point against the electric field. Next, derive an expression for potential due to a point charge. From figure, Q is point charge at origin O. R is distance between O and P. X is distance between O and A. Dx is distance between A and B. E is electric field due to point charge Q. Q0 is unit positive charge is equal to +1 coulomb. According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught, Q0 by x square. But Q0 is equal to 1. Therefore, F is equal to 1 by 4 pi epsilon naught, Q by x square. Mark as equation 1. Small work done in bringing a unit positive charge Q0 from A to B is dW is equal to minus F into dx. Mark as equation 2. Negative sign indicates that work is done opposite to the direction of electric field. Substitute equation 1 into we get dW is equal to minus 1 by 4 pi epsilon naught, Q by x square into dx. Mark as equation 3. The total work done in moving 1c of charge from x is equal to infinity to x is equal to r can be calculated by using integration. Therefore, W is equal to integration infinity to r of dW. Substitute equation 3 in this equation we get W is equal to integration infinity to r of minus 1 by 4 pi epsilon naught, Q by x square into dx. Take constant term common. That is, W is equal to minus Q by 4 pi epsilon naught, integration, infinity to r of 1 by x square dx. On simplification, that is, integration of 1 by x square is equal to minus 1 by x. Substituting in above equation, we get W is equal to minus Q by 4 pi epsilon naught into bracket minus 1 by x infinity to r. The above equation can written as W is equal to minus Q by 4 pi epsilon naught into bracket 1 by r minus 1 by infinity, where 1 by infinity is equal to 0. Then W is equal to minus Q by 4 pi epsilon naught into bracket 1 by r. But V is equal to W by Q, where Q is equal to 1. That is V is equal to W. The final equation will be V is equal to 1 by 4 pi epsilon naught Q by r. This is the expression for electric potential. Comment for PDF. Next video we discuss potential due to an electric dipole. Don't forget to subscribe the channel for more updates.